You guys do all necessary inventory planning. You keep safety stocks. You have min-max inventory setups. You have Kanbans. But still, you are facing inventory shortages. You miss revenue. You are not able to support extra customer orders. Your inventory dollars are going up. Have you ever thought what optimal forecast accuracy you need to keep to minimize or optimize your operational cost? In my opinion, forecast accuracy too high or too low, both are bad. You need to find out the optimal point and plan against it. So if you are working in the industry and facing similar situation or problem, you are looking at the right video. My name is Kamor Iqbal, a PhD from Wichita State University. I have been working in the industry for the last 10 years. I work in textile, I worked in food service, I work in high tech, I worked in power electronics, you name it. And I realized that people working in the industry either do not apply these concepts in the right way, or in some cases they are not even aware of the advanced supply planning or inventory planning concept. So I'm here to help you. I'm planning to load my video series that will touch each and every topic. So I will be discussing the concepts, the real problems, the case studies, and above all, I will propose solutions. So at the end of my video series, when you are done watching each and every video, I can assure you, you will have enough knowledge and understanding and also enough confidence that you will be able to make big impact in your company. So let's start with the very first topic, safety stock. Okay, so let's get started. Before we discuss advanced topics with regards to safety stock, I think it's a good idea to discuss the basic concept behind safety stock and what is the basic formula that is being used. Okay, so very first question can come to your mind: why do we need safety stock? Why company carry safety stock? Because demand is not constant. Demand variability can happen. Demand fluctuation can happen. And also, company can experience some supply issues, quality issues, and that can undermine their ability to produce products. In that case, company might not be able to support customer orders, so their revenue might be impacted, right? And there can be some scenario when customer wants to place more orders, meaning some additional demand, and if you have some extra stock in your shelf, then you can support those demand, right? So you can make more revenue, more profit. But at the same time, you do not want to keep too much of additional stock. So there should be some rationale or something that can tell you that this much amount of safety stock would make sense, or this much amount of safety stock or additional stock can optimize your revenue, your profit, right? So the very basic formula that is mostly used in the industry and also in the literature, we call it traditional safety stock methods. So this formula can be divided into two areas. One, when only the demand is variable, and second, when demand and the lead time both are variable. Okay, so let's discuss the very first method or very first concept with a very basic or simple example. Okay, stay with me. I'm gonna share my screen. Okay, so case number one. So in the first case, demand is variable but lead time is constant. The formula that you see in your screen is used to calculate safety stock. So safety stock equals Z times square root of lead time multiplied by standard deviation of demand. So here Z is called Z-score. The value of Z can be found from normal distribution table. Why is that? Because in in calculating the safety stock, we assume that demand follows normal distribution. So this is a basic assumption behind using this safety stock formula. Okay, and you can I will go over the derivation and the proof of this formula in future videos, but for now we should just keep this assumption, as we see in the literature, that the demand follows normal distribution. In some cases, the demand may not follow normal distribution. So what would happen in those cases? So I will also discuss in my future videos when I will be talking more in detail about safety stock methods. Okay, so let's and also, I forgot to tell you the value of Z. Also, when you're going to look into normal distribution table, the value of Z would depend upon how much service level you want to keep. Okay, meaning customer service level. It depends on the company's direction, company's policy. You might want to talk to your manager or your company policy, how much customer service level they would want to keep for given customer or given SKU. Okay, but for our calculation we would use 95% of customer service level. Okay, let's go to example 1, where we can find out the data. Okay, so as I told you, service level we are setting here 95%. Okay, so against 95%, when we go into Z table, we find Z equals to 1.65, right? So, and the standard deviation of demand, we assume that and the standard deviation of demand for a given data set is 10 units a month, and lead time is 3 months. Okay, these are arbitrary values. Okay, it will depend totally on your data set. Okay, whatever data set you have, you need to calculate the standard deviation, and you also need to know the lead time of the products, okay, from your supplier. So when you put these values into safety stock formula that I showed you here, Z and square root of lead time and standard deviation of demand, then you will get the safety stock for this commodity 28.5. Okay, so this means that you will need to carry 29 units in safety stock if you would like to maintain service level of 95%, right? In other words, 95% of the time you should be able to support customer orders, right? So in this case, in the beginning I told you, we assume that demand is variable but lead time is constant. In the second case, we have demand and lead time, both are variable. Okay, if that happens, then for safety stock formula, there's some modification you need to make in safety stock formula. So the formula that you see in your screen now is used in this case. Okay, so Z times square root of standard deviation of demand square into lead time plus standard deviation of lead time into average demand. Okay, and then you take the square and then you take the whole square root. Okay, so this factor, when you highlight, is blue, and this factor I highlight with maybe yellow color. Okay, so the blue thing's called demand variability and the yellow thing is called lead time variability. Okay, so I will go over the derivation in my future videos. How did we come up with this formula? Okay, so in that video you will understand step by step all the mathematical derivation. Okay, so let's have one example for this case as well. We assume service level 95%, and then when you go into Z table or normal distribution table, you find Z value 1.65. okay, and then you have a demand 100 units a month. Okay, and standard deviation of demand,
you have, I assume that 10 units a month. It totally depends on your data set. Okay, and lead time is 3 months. Standard deviation of lead time, I assume that 0.5, just to make things simple. And then when you put all these values in the safety stock formula, you get 87.3. Okay, so in other words, you would need at least 88 units in safety stock to support 95% service level. So in other words, 95% of the time you would be able to support customer orders. Okay. Okay, then one question may come to your mind, that why safety stock in second case is higher than first case, right? In the first case we had just 28 point something, right? 28.5, here 87. The simple answer to this is we have now more variability into the system. We have demand variability as well as we have lead time variability. Whereas in first case we just had demand variability. So the more the variability into your system, the more safety stock you would need to carry. Okay, okay, that ends today's session. I will talk to you more about safety stock in next video. Thank you.